Hello math students, welcome to your first video math lesson. Please have your notebook out and be prepared to take beautiful organized notes today. To try and help in your organization, I color-coded the slides to help signify when the warm-up was, when you had formal definitions, and then the slide for examples. Alright, let's go. Before we officially start the lesson, we obviously have to do a warm-up to get your brains exercising and ready to do some math. So whenever we do the warm-up in a video, I want you to pause the video and try the warm-up. I don't want it to be a stressful situation where you feel like you have to look things up and get upset if you don't know the answer. This is really just to warm up your brain and get you ready for the lesson ahead. So don't spend more than 5 minutes, I would say, on the warm-up. About 5 minutes is a good amount of time before coming back to the video and seeing what I get. So at this point, go ahead and pause me. Welcome back. Here's what I got for the warm-up. So in the first one, I just sketched a line that passed through the point 1, 0, so that's that first point up here. And then for the slope, I went down 3 over 2. Down 3 over 2. I plotted 3 points and then connected them for my line. You could just do 2. You only need 2 points to make a line. And then in the second problem, sketch a square root function that has been shifted to the left by 3 and up 1. So that means the vertex of the square root is at -3, 1. So I just plotted that point and sketched the square root. Since it's just a sketch, I don't really have to include a bunch of extra points. That would be if I were accurately graphing. So note that it says sketch. So these are sufficient for sketches. If you were told to accurately graph, then make sure you include at least 3 points in your accurate graph. Cool. Hopefully this went okay for you. You remembered what a square root looked like and were able to do this. If not, don't worry, I have notes ahead. So the first notes that we're talking about are linear equations. So I included both slope-intercept form because that's what you're more familiar with, which is just the classic y equals mx plus b. So I like including this so you can really understand where the titles of each of these come from. So slope-intercept just means the equation is written to include the slope and the intercept. See where that word comes from? Slope-intercept. M is the slope and the intercept is b. And then of course there's the form that I prefer because it is so much better, is the point-slope form. So point and slope are referring to the slope again here, and then the point x1, y1. Okay? So for point slope, which is what we will be using, whenever you are asked to write an equation of the line, you should always think, alright, I need the slope, I need a point. Those are the two things you need to write an equation of the line. And then just in case you forgot, I reminded you of the slope formula down below, so if you had forgotten that, go ahead and add the slope formula to your notes. Otherwise, we're going to keep going and I'm going to show you an example. So write the equation of the line in point-slope form that passes through the set of points. Okay, so my point-slope form, I remember, will always just look like this. Y minus y1 equals m times x minus x1. So whenever I have to write an equation of the line, I usually just write that. So I write the formula, and then that helps me remember I need slope and a point. So for each of these, I already have a point. I just need to find the slope. So I'll use my equation for slope. And then I'll fill it in. I like labeling them just so I don't lose track. It's easy to kind of mix up your numbers here, so labeling really helps me. There's my slope. So then the equation of my line will be y. For my point, it doesn't really matter which point you choose, but I'll use that point to avoid negatives. There it is. There is my equation. Cool. I think that you've got this. So, since we just did part A together, I want you to try part B on your own. So I will be doing the problem silently. I'll be doing the problem silently, and I want you to do the problem silently as well. And I want you to look down at your own paper and work. So no looking up at me. Look down at your own paper. Go ahead and copy down the points, obviously. Then look down at your own paper and work on it yourself. Don't just copy me, okay? So I'll be working and you'll be working. And then we can compare at the end. So I found two different equations that will both work. If you got either of these equations, excellent job! If you didn't, then maybe you need to log on to IXL to get in a little bit more practice. This is something you should practice. Okay, just a couple more notes on lines. I wanted to show you some of the characteristics that you are expected to know. So you're expected to know that parallel lines have the same slope. In case you forgot what they look like, parallel lines look like this, where they're just like running like train tracks next to each other and they never touch. So parallel lines just go next to each other, they never touch, so same slope. So if I have this equation, y minus 3 equals 2x plus 1, that would be parallel to a line that just has the same slope. Oops. Well, it doesn't matter. So I could just write any line that has the same slope. They're parallel to each other. Okay. Perpendicular lines, meanwhile, are lines that form a cross. So they form a right angle with each other. That's really important. So the angle that perpendicular lines form is a right angle. Okay. These have opposite reciprocal slopes. So if I have that same line that has a slope of 2, the opposite reciprocal, well, this is positive 2, so it will turn negative, and then the reciprocal of 2 is 1/2. So here's an example of a line that is perpendicular to that. So you take the opposite reciprocal. So that's parallel and perpendicular. And then at the bottom, I remind you of the equations of horizontal lines and vertical lines. So horizontal lines are always of the form y equals then some constant, and these have a slope of 0. So lines like this have 0 slope. And then vertical lines are always in the form of x equals some constant, and vertical lines have an undefined slope. Okay, and if you're confused why the slope are 0 or undefined, go ahead and choose 2 points on a horizontal or vertical line. Choose 2 points on them, and then try to solve the slope using the slope equation. That will explain why those are always 0 or undefined. Okay, so now we're going to do some examples that use these linear line facts. So example 2, sketch the lines y equals 2 and x equals -1 on the xy plane. Okay. So here's my xy plane. I'll do y equal 2 in blue. So y equals 2 at this point right here. So the line is just the horizontal line that goes through 2. That's it. And then in red, I'll do x equals -1. X equals -1 right here. And so the vertical line just goes through x equals 1. Okay? Or x equals -1. So I'll add the little labels if that helps things, helps it make a little bit more clear. But drawing horizontal and vertical lines or finding their equations is super duper easy. Alright, B. It says line M passes through the points 1, 4 and -3, 7. Line N, so a different line, is perpendicular to line M and passes through the point 1, 4 as well. We need to write an equation for line N. Okay, so again, if I'm writing an equation for the line, I'm just going to remind myself of my little equation, my point slope equation. And I already know my x1, y1, it's this right here. I was given a point, but I need to find the slope. So I'm going to have to find the slope and do a little work with it. So I know I have 2 points for line M, which is perpendicular to line N. So if I can find the slope for line M, oh, I should have chosen different letters. Oh well. If I can find the slope of line M, then I can also find the slope for line N because it is perpendicular in the opposite reciprocal. So let's find the slope. This is for line M. So the slope for line M, we'll use those points. So I can find the slope 7 minus 4 over -3 minus 1 will be 3 over -4. So that's for line M. Line N will be the opposite reciprocal. So the opposite, if this previous slope was negative, will be positive, and then I take the reciprocal like that. So I flip the fraction. So I have my point, I have my slope. Now let's put it all together to write my equation. So this will be y minus 4 equals 4/3 times x minus 1. That is my equation for line N.